This video is going to be on factoring polynomials. The process of writing polynomials as a product is called factoring. It is an important tool to solving equations and for simplifying rational expressions. Unless noted otherwise, when you are asked to factor a polynomial, you can assume that you are looking for the factors that have integer coefficients. If a polynomial does not factor using integer coefficients, then it is considered to be prime or irreducible over integers. For instance, we have x squared minus 3. That is irreducible or prime. We cannot factor that polynomial. Polynomials can either result into a monomial and another polynomial, or simply factoring is the reverse of the distributive property. So the first type of thing that we're going to do is removing the greatest common factor, or factoring out the GCF. So let's say in a real life situation that Cassie is dating Alonzo. Alonzo. Plus Sandra, or Chandra, is dating Alonzo. Who is the common factor in both of these situations? Alonzo. So one day Cassie finds out about Chandra, Chandra finds out about Cassie, and they say they are going to factor Alonzo out of their lives. So when we factor out Alonzo, right, we cannot kill Alonzo. That is quite illegal. So we just factor him out in front of the house, which will be your parentheses, and we are left with who? Cassie sitting in the inside plus Chandra sitting in the inside. Now, that is considered to be factoring out the greatest common factor. So if we get to real numbers, such as 6x cubed minus 4x, well, we have to look and see, what does 6 and 4 have in common as a number? We can both say that 2, right? And do they both have variables? Yes. What is that common factor? X. So whatever you factor out is what you want to take out of the expression. Not by subtraction, but it's technically like by division. So if I technically divide this by 2x, 2 goes into 6, how much? 3. And if I had 1x at the top and 3x's at the top, 1x at the bottom and 3x's at the top, then that means I'm left with 2x's. The same thing goes here. Now, 2 goes into 4, 2 times, and then I should be left with no x's. Again, as I said before, factoring is the reverse of the distributive property. So if I went back and redistributed any of this, I should end up back to my original problem. So let's try again. I have negative 4x squared plus 12x minus 16. What can I factor out? Well, 4, 12, and 16 all have a 4 in common. So one thing that I always want you to remember is we don't like negative people in our lives, and we don't like negatives in our problems. So I factor out a negative 4, and again, factor out means you are going to divide. So I divide this by negative 4. 4 is what? Cancel out, and I'm left with x squared. Divide this by negative 4. Negative 4 into 12 gives me a negative 3. A positive divided by a negative is still going to give me a negative. And then last but not least, divide this by negative 4. 2 negatives make a positive, and that should be a positive 4. Now we have factored out the greatest common factor. The next part is special factoring. We have the difference of squares, which is a squared minus b squared equals to a plus b and a minus b. At the beginning of the semester, I gave you a list of all of the perfectly squared numbers. You should be familiar with them so that you can easily factor the difference of squares. So if I have x squared minus 25, well, is x perfectly squared? Yes. Is 25 perfectly squared? Yes. X is perfectly squared for x, and 25 is perfectly squared for who? 5. So this should be x plus 5 and x minus 5. It does not matter which order you put it in, long as you know your perfectly squared numbers. So in that long list, I gave you 196. Is 196 a perfectly squared number? Yes. For who? 14. is, is 169 a perfectly square number? Yes, it is for who? 13. So this should be plus 13 and this should be minus 13. A difference of squares is just literally you're looking for that perfectly square number and separating them by the plus and the minus. Okay, so if I go a higher up, right, this is still a difference of squares. Even if I do not use a squared, a fourth exponent is the same thing. So is 16 perfectly squared? Yes, for who? 4. But this would be 4x squared minus 9 and 4x squared plus 9. Now, if we look back at this, are these two binomials now perfectly squared or differences of squares? Well, yes, they are. So we can factor this to be, 2x plus 3 and 2x minus 3. But however, we cannot factor x squared plus 9. Why is that? We only have a difference of squares. We do not have a sum of squares. So my answer would just be 2x plus 3, 2x minus 3 times 4x squared plus 9. Now, if I finish this off, by my own rule, what did I just say? We have x squared plus 36. So can I factor this? No, we would consider this to be prime or irreducible. Okay? The last piece that I'm going to do is the sum or difference of cubes. So if I find that my numbers are perfectly cubed, I label them out as the A and the B. Okay? The difference in sum of cubes is a cubed plus b cubed equals to a plus b times a squared minus ab plus b squared. So, with that being said, what is my perfectly cubed number for x? Well, x. What is my perfectly cubed number for 125? Well, that would be 5. So now it is simply you're taking now your a and your b and you're plugging it into the formula. So my a is x plus my b is 5. Then this should be x squared minus 5x plus 5 squared, which is what? 25. And then I have found my sum and difference of cubes. All right, I will make another video on factoring trinomials, and then that will be it.